circuits. In this segment, we're talking about RF materials. Now, by RF materials, traditionally those were materials having a dielectric constant somewhere between 2.20 and 10, and a dissipation factor between 0.001 and 0.003. Now, these were measured at 10 gigahertz, which kind of delineates the fact that it is an RF microwave material. In the past, those materials were Teflon-based, usually required special processing, but with the advent of new material creation, within the last 20 years, there's been hydrocarbon materials, PPO materials, PPE type materials, which have started to reach into these performance levels. Applications in general have been either very high power or very low loss. It doesn't mean that you don't need high power and low loss. Of course, that's usually required as well. But there's materials that don't require high heat dissipation or power handling capabilities, and those are more concerned with the loss of the material, its ability to be able to send a signal through or across that material, and its tight dielectric control, so we have very tight impedance across that circuit. With the high power applications, there's been an advent of more ceramic filled materials, or materials with a focus specifically on thermal conductivity, and those are generally called either TC or HTC materials, and those are finding their ways into a lot of the high power applications. The temperature of the circuitry and the temperature of the devices have become of increasing importance relative to how that circuit functions, as well as the loss of the signal along that conductor. In those cases, they've actually wanted to dissipate heat along the conductor itself as opposed to just under the device, which had been traditional. There's also been an advent of what we call RF-like materials, or materials that have very controlled decay and very low loss. By very low loss, that term gets a little mixed from the traditional understanding. Generally, they have a dissipation factor somewhere below 0.005 at 10 gigahertz. And they're finding their way into the lower power RF. Doesn't mean they couldn't be used at higher powers, but different thermal management techniques may be needed. But they're also being utilized in the high-speed digital fields as well. And those are coming out of some of your more traditional material suppliers as well, and they tend to have characteristics more like FR4.